Today I'm going to talk about LeetCode question number 152, maximum product subarray. Given an integer array nums, find the contiguous non-empty subarray within the array that has the largest product and return the product. Subarray is a contiguous subsequence of the array. So for example, this can be a subarray, but it cannot be broken into different pieces here. Like 2 minus 2, 4. Okay. So for example, this first example, 2, 3 has the largest product of 6, so we return 6. And this example, the largest product is 0, so we return 0. So how will we go about this question? Well, let's say we have this array here. How will we find the subarray with the largest product? Well, we could go one by one for each element. So we have here, look at this subarray, then look at this subarray, then look at this subarray, and then find the maximum. And then starting from this element here, look at this element, then look at this subarray, and then finally we have this element here. And if we had a last element here, we will look at this element and then this element. Subarray starts from this element, and so on. And then type complexity of that would be O of n squared. But we can do better. We can actually do an O of n solution. How? Well, by using dynamic programming. So how will we go about it? Well, if the array was like this, it contained, all positives, it would kind of be easy. We would just go through the array and of course find the maximum product. Well, what we would do is keep like a max variable and then a prod so far variable, and update the max as we go along and update the product so far variable as we go along. So for example, product so far would be 1 and max would be 1, and then we get to this element here. Product so far would be times 2, which equals 2, and then max so far would be 2, and so on. But what happens if we have actually an array with negatives? It doesn't have to be all negatives, but with some negatives. And that in this case becomes trickier. Let me just erase this here. Okay. So let's say we have this array here, and we have our max variable and our product so far variable. So we are at -1 right now, so max so far would be -1 and prod so far would be -1. And then we look at this subarray here. Max now would be actually, so product so far would be actually times -2, which equals 2. And then max would now be 2. And then we look at this guy last, so product so far would be times -3, which equals to -6, and we keep our max at 2. But we can see actually the maximum product is actually -6. The answer is 6 in this case. But we calculated it to be 2. Why is that? Well, even though we calculated -1 times -2 to be 2, we didn't take into account that -2 times -3 would be 6. Okay? So we kept the product so far here. We kept the max here as being 2, but we didn't take into account how minus 2 times minus 3 would be 6. So what could we do in this case? Well, instead of keeping a product so far, what we could do is keep a min so far and a max so far variable, which initially be minus 1. Okay, now what's the point of this? So max so far would, within the range we're looking at, so at that point, keep track of the maximum that we've seen so far within the subarray. And same for minimum so far, we keep track of the minimum so far we've seen in subarray. And this would help in case of negative numbers here, because if you have a negative number and say min so far is negative, then we can multiply those together and get a new max. So I'll show you an example here. So I'll do the example up here. So right now max is minus 1, min so far equals minus 1, max so far is equal to minus 1. Okay, now let's look at this range, minus 1 and minus 2. And minus 1 times minus 2 would be 2. So within the range of minus 1 and minus 2 here, max so far would be now 2. And min so far would now be minus 2. Okay, within this range, minus 2 is the smallest we've seen so far. And now max would be obviously 2. And now let's look at this variable, minus 3 here. So what we would do here at minus 3 is multiply by min so far and max so far, and take the min in min so far and take the max in max so far. So for example, 3 times minus 2 is now 6. So it'd be 6. And max so far would be now within, so we're looking at this range here, would now be minus 6. Okay, and now this max here would be updated to 6. Min so far would now be updated to, so we're looking at this range here, would now be minus 6, and max so far would now be 6. And what if we had like a 4 here? We would do the same thing. So for each min so far, max so far, multiply by 4. So this would be minus 24, this would be 24, and then we take the maximum, which would be 24 here. And yeah, so that's how we go about it. There's one tricky case I want to bring up. So what if we had like minus r 1, 2, 0, 4, 5. If we were to implement this max, min so far, max so far method, then we would have, min so far would be equal to, then basically with this 0 here, if we multiply it by min so far and max so far, they'd zero out. And then for each subsequent element, we'd be multiplying by 0 every time. So then this, like, this would be 0, this would be 0, and then 4 times 0 would be 0, 4 times 0 is 0, 5 times 0 is 0, etc. So what are we going to do in this case? Well, instead of assigning these 0, we're going to normalize them to 1. It's kind of like our reset. So what would happen is, now if we were to multiply 4 by min so far and max so far, it would now be 4, and etc. Okay, so that's what we're gonna do here. And the time complexity of this would be O of n. So now to code this up, what I want to do is have my max variable. I'll call it final max, which is going to be nums of 0 initially, and I'm going to have my min so far variable, which is going to be nums at, again, position 0, and max so far, which is again at num 0. So now I'm going to iterate through the nums array, starting from position 1. And val is going to be at that index. So what I'm going to do is, first check if val is equal to 0, then what I want to do is normalize these to 1. Okay, and then what I'm going to do here with final max is actually do final max equals the max of val itself and itself, and then continue. Or else what I want to do is calculate prod with min, okay, which is going to be min so far times val, and prod with max to be max so far times val. So then I just calculated these, the products of a min so far times val and max so far times val. And now what I'm going to do is reassign min so far to be the minimum of prod with min, prod with max, and val itself, because val could always be smaller than these two. And same with max so far. It's going to be the maximum of these three. Because remember, within the range, we want to get the maximum of the range so far. Okay? And val makes sure. So for example, if we had like -1, 0, 5, 6 or whatever, then obviously the min so far here would be -1, the max so far would be 0, and if we found 5 at this value here, we want to forget about this subarray here and start the subarray with here. So the val here takes that into account. And min so far, yeah, it looks like the minimum of this range here would be, which would be -5. Okay, and then finally what we want to do is final max here. This is going to be the maximum of itself, and min so far, and max so far. Okay. Then lastly, what we can do is return final max. Okay. So yeah, this will take O of n time, and I'll take it for a dry run. Okay, now I'll use more test cases. Looks good, and I'll try submitting. Okay, awesome. Thanks for watching.